Okay, applications of exponents and logarithms less than 8. So now we're talking about growth and decay. In this lesson, we're talking about half-life and double time. So these are the questions I had on that last assignment that I didn't mean to put there. So review, in the last lesson, we were just talking about logarithms and exponential growth. We used this formula a lot, okay? So P was always your initial principal amount. A was the amount after. Your 1 plus I is 1 plus your interest or your rate. And then your N is your time, okay? This was compound interest. We also use this for growth and decay, right, with population. So if it's growth, you're adding your percent increase. And if it's decay, you're subtracting, okay? So if it's growth, it'll always be greater than 1. If it's decay, it's less than 1. So you can have to determine the base of the exponential function from the given information. So let's consider the following. If you have a population of animals increasing by 7% every year, after 1 year, the population is 100%. So, or after 1 year, it'll be 100% plus 7%, so it'll be 107%. 107% changes to 1.07. Okay? Value of a tractor. If you're depreciating, this is a word that you'll see in the diploma. Does this mean increasing or decreasing? Yeah, so what do you want to do? Subtract from what? So it'll be, yeah, 1 minus 0.15. You're changing this 15% into a decimal. 1 minus 0.15, which is what? Yeah, 0.85. So that'll be your base. Okay, are there any questions with that so far? Do you guys understand your base, 1 plus or 1 minus, depending on what the question's asking? Okay, so let's talk about this one. In the diploma, there will be questions like this, but it's not going to have A, B, C parts. It might just give you the information and ask for part C, okay? So it's not going to be guiding questions like this for your diploma. You're going to have to, so these ones right now are really good for class, but you're going to have to understand in the diploma to get right from this beginning part to this last part. You're going to have to know how to do these steps without this in between, okay? So if you have a quantity of water contains 500 grams of pollutants, there we go. It's been a long day. I don't understand why I can't speak. Each time the water passes through a filter, 12% of the pollutants are removed. Oh, there's a reason I teach math. Jeez Louise. Okay, if the mass is an exponential function of time, state the base of the exponential function. So our base is always 1 plus or 1 minus. So each time the water passes through a filter, 12% are removed. Are we adding or subtracting? Yeah, you're subtracting. If 12% are removed, so it'll be 1 minus what? Good, which is equal to what? So this is your base, okay? Okay, guys, focus. So in this case, the exponential function, so our exponential function is always in this form. And it can be modeled in this form. So m equals a times b to the t. They're both the same, okay? So it's just saying m is your mass, a will be your original, and then your b is your base, your t is your time, okay? So a is your original mass. A is always like this A is always going to be your original or your initial payment or whatever. The one on the left-hand side will always be what happens after everything goes on. Okay? So if I have a quantity of water containing 500 grams of pollutants, what am I doing? If I have 500 grams of pollutants, what is this 500 going to be? Yeah, your initial, so it'll be your A. So we'll have m equals 500. Yeah, so now we're base. You already have it, 0.88. And then they have t up here, so it'll be the exponent t. Is everyone with me so far? Determine to the nearest gram the mass remaining after the water has passed through 4 filters. So each time a water passes through a filter, 12% is removed. So your T would be probably your number of filters then, hey? So you're going to have to, so each time the water passes through a filter, 12% are removed. So T is your number of filters. Yeah. So if your T is your number of filters, if we're given after it passes through 4 filters, your T will be 4. So you just substitute this into your equation. 500, 0.88, exponent of 4. You could put this right into your calculator. You could graph it and then find, so you would have to graph where x is your T and then go x equals 4. You could do that way. Or you could just go 500 times 0.88 to exponent 4. That's what you guys got? So to the nearest gram, what would we round to? Nearest gram. Any questions about part C? No. So this next one, if I give you, see how many filters are after, or when it's at 150 grams, how do I do it? Intersect. Yeah, you can find the intersect. So what am I graphing? What's my y1? What's my y2? Okay, I'm going to let you guys do it. So you guys graph this and tell me what to do. What did you get? So can I have 0.42 filters? No. So how many filters should I? Yeah. 9. So 10 filters are needed. Nope. So if it's like whole objects, if it's like filters, number of houses, number of people, number of years, you always round up, okay? Because you're not gonna. Because if you round this to 9, it's not gonna be 150. It's gonna be less, right? So 10 filters are needed.
Is that your X? Still goes
against
the law of rounding though.
Yeah. If it's saying round to the nearest tenth, absolutely that's what you do, or nearest whole number. But if it's objects like this, you just have to know you have to round up every time, okay? Let's do this really quick algebraically, so you guys understand how you would do it. You don't have to write this down, just follow along, okay? So if I have 150 equals 500 times 0.88 to the t, we're solving for t.
Divide by 500.
Yep, divide by 500, good.
Yeah.
What's 150 divided by 500? You can just leave it as a fraction.
Oh, wow. Dylan doesn't know?
15 divided by 50.
Yeah.
That's like 3.
I knew that.
So 1/3? Is that right? Holy balls.
It's not 1/3.
I lied,
Is it?
okay? It's like 3/10.
Yeah.
Dylan, you were so wrong.
Equals Okay, guys, focus, please. Because you guys talking about this is distracting all of them because they can't hear what I'm saying. Okay. Yeah. Thank you. So I have a number equals, and now I have, guys, I have an exponential equation here. What did we talk about last time? As soon as I'm solving for that exponent on, or that variable that's an exponent, what should I do? Does anyone know what I should do? What's my next step? Change it to a log? So am I setting both sides to a log, or am I changing to logarithmic form? Yeah. You change to logarithmic form because as soon as this exponent is a variable, as soon as you change to logarithmic form, that variable will be what you're solving for. So I can change this to log. What's my base? Base is always the same. Your base here is 0.88, so your base of here is 0.88. Your value up here is your new argument equals t. Okay, so you can put this into your calculator. So log of 3/10 divided by log of 0.88 is equal to t. So your t is going to be 9.42. So it'll be 10 filters. Yeah. If it asks for an exact value, this right here is your exact value. Okay. But if it says filters, number of filters, then it'll be 5 filters. Or, sorry, 10. Okay, is there any questions with this one? Yeah, for sure. Did everyone have that copied down? Let me go back. Okay. Okay, so class example 2. Number of students in a new college is currently growing at a rate of 4% per year. So let's stop right there. If I'm growing at a rate of 4%, what is this value going to be in my exponential function?
1.040.
It'd be 1 plus 0.04. You're close. So this right here, growing at a rate, adding, so it'll be 1 plus 0.04. I didn't say you were wrong.
Okay, well, that's a shit.
So this will be my base. Is everyone okay with that so far? Did I hear yes or no? Okay, good. If the number of students continue to grow at this rate, it is projected that the college will reach its maximum capacity of 5,650 students in 4 years. Okay. Determine the current number of students at the college to the nearest 10 students. Okay, so if we're determining the current, so I have y equals a times b to the x. Y 1.04, that's my base, so that's my b. Okay. It's my b, 1.04. Do I know why? Yep, why? Why is my y 5650 and not my a? Yeah, it's your maximum capacity, so it's after whatever happens, okay? We don't know the initial amount, so do we know our a? That's what we're looking for, okay? Do we know our x? Yeah, why? Why is it 4? Yeah, after 4 years. So if our rate is growing at 4% per year, after 4 years, your 4, or your x is your 4, okay? Is everyone okay with this so far? So if you have to do this for the questions, this might make it a lot more simple and laid out for you guys, okay? So now that I know this, I'm solving for a. Okay, so I have y equals a times b to the x. So I have 5650 equals a times my b is 1.04 to the exponent 4. Yeah, you just have to isolate your a here. Hmm?
Oh, no.
Okay, so if I'm isolating a, what do I do?
Divide by 10? No.
No, you're not dividing by a.
Divide by the 11 point.
Yeah, to exponent. Mm-hmm. So if I divide both sides by 1.04 to the exponent 4, your a is isolated there. Okay? So 5650 divided by 1.04 to the exponent 4. To the nearest 10 students. So go 5650 divided by
4830.
nearest 10 students.
48 or 30. Alright.
Yeah, so if I have 4829.6. If I'm rounding to the nearest 10 students, it'll be 4830. Does everyone understand the 30? Round to the nearest 10? Yeah. Are there any questions with this problem? This part?
No.
You guys good?
I
Oh, I love that time change. I could gain an hour in a day.
know, but my feeding's gonna take off.
It's Saturday night. It's like, well, it's Sunday morning at like 2 or 3 a.m.
I thought it was always gonna be Sunday night.
That's what I thought too, but I don't know. Okay, so let's start B. So the governors of the college decided to expand the school by adding more buildings. So this will increase the capacity to 8,000. So now we have a new maximum capacity that this college can hold. So in order to determine the number of years it would take before the college reached full capacity, one of the governors assumed the same growth rate and solved the equation 8,000 equals 4830 times 1.04 to the n. So we found this right here was our original, right? That's our initial number of students. So we just solved that. So that number comes here. We have a new maximum. So now we want to know how many years it's going to take for our college to reach this. Okay, so is everyone okay with where this came from? Everyone's okay with that so far? Okay. So there's a couple different ways you could have solved for this. We're just gonna correct this work. If I were doing this, I would have divided by 4830 to both sides, and then change that into logarithmic form. Okay. Do you want to just do that?
Yeah.
Okay. Let's just do that because this might confuse some of you, and it's just a lot more work than we need to do. So I'm just writing it over here. You guys should have enough room. 1.04 again. Okay, so let's solve for n on our own. Okay. First step we do is what? Divide by 48. So I'm just going to leave 8,000 over 4830 right now. So I have 8,000 over 4830 is equal to 1.04 to the n. How would I solve for this now? Put it into logarithmic form. Perfect. Okay, you guys know. Someone else tell me how to do this. How do I change this into logarithmic form? So it'll be log 1.04. Is that my base or my argument? Yep. What's my argument? Yep. What's this equal to? N. Perfect. So you see how this right here is a lot nicer than all of this stuff? This is how I would solve this if I were you. Okay? Or you could graph both sides and then find the intersect there as well. But this seems pretty straightforward. So if you're putting this into your calculator, go log of 8,000. 8,000 divided by 4830. And then you're dividing this by log of 1.0. Oh man. 0.04. So everyone okay with how we put this in our calculator?
Yeah.
So I got 12.86. This is wrong. You just have to figure out that. You have to find the mistake here. So n equals 12.86. In order to determine the number of years it would take to reach full capacity. So if it's 12.86, what is the total number of years it would take? Yep. Did you go log of 8,000 divided by 4830, close your bracket, divided by log of 1.04? Oh, yeah, that'll mess you up. So if your argument's a fraction, make sure to put that whole fraction into there. So 12.86, so let's round to the nearest number of years. Good job. I don't know. So this n came, I'm just going to check their work to see where this where they went wrong. So log, they set each to a logarithm. And this n comes in front. But this n is only affecting, okay. So I'm just going to explain quickly where they went wrong. So this 1.04 to the n, that n is only affecting that 1.04. So if they were to go on, they would have to go log of 8,000 equals log of 4830 plus log 1.04 to the n. This would just be your power law. Do you guys understand why? Because when you're multiplying two arguments, it's the same as adding the logarithms. So this n is only affecting this one logarithm, not both. Does everyone see why they went wrong there? And how this is actually a lot faster to do. Okay. Are there any questions on this example, you guys? So far? Okay, so let's talk about half-life and double time. So if I'm ever talking about half-life, pretty straightforward. Your base is 1/2. Okay, that's going to be your formula. Your A is going to be the radioactive substance after it happens. Your A naught is going to be your initial amount of radioactive substance. Your T is the present time. Your H is your half-life. We'll talk about that soon. Okay, so I'm just explaining it to you. So it's exactly the same as what we've been working with. Now you just have a fraction as an exponent. So for doubling time, your A is your whatever happens after. Your A naught is your initial. Your for doubling time, your base is now 2 because it's doubling. Your T is your present time. Your D is your doubling time. Okay, so we'll just do some questions there. So, April 1986, nuclear accident at Chernobyl contaminated the atmosphere with quantities of radioactive iodine 131. Radioactive iodine 131, that's just what it's called. That's not, this 131 doesn't mean anything to us, okay? So that's just what the iodine is called. If the half-life Half-life is 8.1 days. Determine the number of days it took for the level of radiation to reduce from 100 to 2 units. So let's kind of lay this out for us. So if I have half-life of radioactive iodine 131 is 8.1 days. That's going to be my H. So your H is going to be 8.1 days. So to reduce from 100 units to 2 units, I have initial amount and I have an after amount. So if I'm reducing from 100 to 2, my initial amount will be what? Yes. And what's my new one? 2. My formula for half-life is A equals A naught times 1/2 to T over H. Do I know my time? Sorry? Nope, that's what I'm looking for. So there's one variable that I don't have that I'm looking for, so let's figure this out. I have my A is 2, so I have 2 is equal to 100. 1/2 to T over 8.1. Everyone okay so far? Yep. So to solve for T, first step, divide by 100. Two divided by 100, you just move your decimal twice, so this would be 0.02 is equal to 1/2 the T over 8.1. It's just 2 divided by 100. You could, which is just 2 over 1, or 0.02. Everyone with me so far? Okay, so now I'm trying to find that exponent that's a variable. How do I solve for T? One-half is your base. Put in logarithmic form, okay? We don't, you would divide by 1/2 if it wasn't your base. If it was your A value, you would divide, but we've already divided by that A value. So I have a number is equal to my base to an exponent. As soon as you have a number equal to a base to an exponent, then you change it to logarithmic, okay? So 0.02 equals 1/2 to T over 8.1. How would I change onto logarithmic form? Do you guys get it? Is 1/2 my base or my argument? Yeah. That's my argument. And what's this equal to? Good. Yes, yes, we would. Is everyone okay with changing it to logarithmic function? Are there any questions with how we did that? Okay, so log of 0.02 base of 1/2. You guys put that into your calculator, okay? So let's solve for that. You will, eventually. We're getting there. So I have log of 0.02 divided by log of 1/2. Or you can go 0.5 if you want, it really doesn't matter. Enter. 5.64385619. Is that what you guys got? So 5.64. So this will be 5.64 equals T over 8.1. Are we done? I hear no. Why not? Yeah, you got to isolate T. So T is being divided by a number. How do you isolate it? Yeah, multiply it by 8.1. So on your calculator, go times 8.1. Enter. Enter. 45.715. Is that what you guys got? You all agree? If I round this to the nearest day, what will it be? you have a question or are you just saying 46? So you see how the formula kind of looks a little tricky, but once you put all of your stuff down, then it's really not that bad. It's just the same thing. Yeah, so this might really help some people. Okay. Yep. Okay, so this right here, so going from exponential to logarithmic, that's where I changed it. So this that I just circled, I'll circle in the red. Okay, what I'm circling in the red, do you understand where we got this? Yeah? So to go from this, I have 0.02 equals 1/2 to the exponent t over 8.1. So as soon as I have that exponent that has a variable in it that I'm trying to solve for, you change it to logarithmic. Because that exponent, this exponent right here, will change to your new value. So this t over 8.1, that comes out here. So it'll be log of your base. Your base will stay the same, so 1/2 will stay the same. Your value for your exponential function will be your new argument for your logarithmic function. So that's where that exponent will come into your new value, so that'll get rid of that exponent for you to solve for t. Does that kind of make sense? So you just have to understand how to go from this red circle to the logarithmic form, and then you can solve for t. And then do you understand how to multiply by 8.1 at the end to isolate the t? Okay, so let's do this last one quick. I'm pretty sure it's a doubling. Yeah, double. So we're trying to find the doubling time. So I have an A naught, I have an A, I have a D, and I have a T.
You have a D? That's weird.
It's been a while.
I know you haven't said that for like a week. Holy smokes. So a patient feeling ill had a sample of bacteria taken from her throat. Sample contained 387 cells. 24 hours later, the sample was recounted and was found to contain 8,012 cells. Find the doubling time to the nearest tenth of an hour. Okay, so first off, let's look at the sample contains 387 cells. Is that going to be your initial sample or your after sample? Initial. So is your initial your A naught or your A? A naught. So what is your after going to be?
2012.
If I'm finding the doubling time, what am I looking for? Doubling time, is that D or is that T?
D.
So you're looking for D. Okay. 24 hours later, will that mean my T? Yes. So if you're looking for the nearest tenth of an hour, 24 will just stay in hours. Okay. So you're just going to have to watch your units because this first one, it says the nearest day. Our H was already in days, so that was fine. This one, our T is still in hours, and we're looking for hours, so we're okay there, okay? So just make sure you're consistent. So they can be in whatever units they are. Just make sure that your T, since it's in hours, your D will be in hours. So you might have to change after. Does that kind of make sense, you guys?
Yeah.
So just watch the units. They could be whatever. You just might have to change them after. Okay, so I have my A naught, or my A equals A naught. What's my base here if it's doubling time?
2.
Yeah, so be careful here. So my base will be 2 to the T over H, or D. So then it would be 8012 equals 387 times 2 to the, and I have my T, it'd be 24 over D. Okay, it's the exact same as before. Pretty much, it's just at the end you're going to have to do something different. So I want you guys to figure this on your own to to the nearest 10th, your answer is going to be 5.5 hours. So try to figure this out on your own. If you can't get it, let me know, and I will go through it with you. So same steps as before. And then when you're done, 1, 3, 5, 6, and 10.